All right, guys, welcome back. And this is going to be our 9.3 instructional video. And this one's going to be super example based. But before we really get into the newer stuff of the section, let's start by having you solve some problems that you already know how to solve. Kind of like how we started 9.2. I want you to solve, or simplify, not solve, 3 times x squared plus x and 3x times x plus 4. Go ahead and pause the video and simplify these as best as you can. Okay? Hopefully you've given that a shot at this point. And what I hope you did is kind of like we were doing with our monomials and polynomials in 9.2. I hope when you see something outside the parentheses being multiplied, you distribute it to everything in the parentheses. So this first one would become 3x squared plus 3x. This one over here would become 3x squared plus 12x. Okay? When we see something outside the parentheses, we distribute it. Kind of a little blast from the past. So where are we going with this? Well, what I want to look at is I want you to solve the following problem using the same logic you did above. 3 plus x times x plus 2. Again, what was I said follow or solve this using the logic you did above, which was if it's outside the parentheses being multiplied by, or if it's sitting outside the parentheses, implying that it's being multiplied by what's in the parentheses, distribute it to everything in the parentheses. So give that a shot for this problem. Okay, at this point, hopefully you've paused it, you've given it your best effort, and now let's talk it through. Well, first of all, let's recognize the difference between this problem and the problems above. Here we have a monomial being a single term, multiplied by binomials. Okay, and we actually did even more complicated versions of this in 9.2, where we multiplied monomials by trinomials. Okay, which are, again, all these are, except for the monomials, are types of polynomials. But here we no longer have a monomial, a single term out front. Instead, we have a binomial. So how is that gonna work? Well, believe it or not, it works almost the exact same way. Except now, instead of having one thing multiplied by the x and the 2 plus 2, we have two things, okay? The logic isn't going to change here. What's out front, this parentheses, is being multiplied by the x plus 2. So I'm still going to need to distribute what's being multiplied by the x plus 2 to the x and the plus 2. But the difference here is since I don't have a monomial, I have a binomial, I'm going to have to distribute multiple things. Sounds confusing, but it's pretty simple. Start with your leftmost term and distribute it to each part of the second binomial. Okay? So I'm distributing the 3 to the x and to the 2, just like I did up here with 3 times x squared plus x. So when I do that distribution, I get 3x plus 6. But I'm not finished there because, again, I don't have a monomial, I have a binomial. So I also need to distribute the x to both terms in the second binomial. I need to do x times x to get x squared, and I need to do x times 2 to get 2x. Okay? The difference in 9.3 when we're multiplying two binomials by each other, as opposed to what we did above, is you not only have to distribute, you have to make sure you distribute everything. This wasn't a big deal when we only had one term out front of the parentheses. But when we have multiple, you have to make sure you distribute both. I got to distribute the 3 to the x and the 2 and the x to the x and the 2. Now, once I do this, this actually goes back to a 9.1 concept. I'm going to try and combine like terms and rewrite this in standard form where it goes decreasing, or my highest power then my next highest power in a decreasing fashion. So first things first, I identify my like terms. I see the 2x and the 3x, both are positive, so I can rewrite this as 5x plus 6 plus x squared. And then, of course, I'm going to rewrite it in standard form where my largest power comes first. And then we go in decreasing order. And what I find out is that when I multiply the binomial 3 plus x times x plus 2, I get x squared plus 5x plus 6. Okay? Seems complicated, but really it's not. The only thing that's changing, and the key to multiplying binomials, is to make sure you distribute both terms in the first binomial to both terms in the second binomial. Everything and every part of the binomial, every term gets a chance to be multiplied. Okay? We got to make sure both terms in the first binomial are being multiplied by both terms in the second binomial. So let's do some examples. Let's do 5m plus 2 times 8m minus 1. Well, to simplify this, number one, if you feel confident, go ahead and try it on your own. Pause the video. To simplify this, again, what I need to do is, because I have two terms here, a binomial times another binomial, I got to make sure I distribute both terms in the first set of parentheses to both in the second set. I'm going to work my way left to right, so I'm going to do 5m times 8m and 5m times minus 1. So I'm going to get 40m squared minus 5m. Now I got to work with my second term in my first binomial. 2 times 8m and 2 times minus 1. And I get plus 16m minus 2. Okay? Again, key to multiplying binomials. If you walk away with nothing else, distribute both terms in your first binomial to both terms in your second binomial. When I do this, now I get to combine like terms. Again, remember from 9.1, like terms are like bases that also have the same exponent. We cannot combine the 40m squared with the minus 5m because they do not have the same exponent. What the minus 5m and the 16m do, so I have 40m squared. Again, minus 5m and plus 16m, that will leave me with 11m. We do minus 5 plus 16. And then, of course, my minus 2 comes on down. And normally, I would have to standardize this, right, putting my largest power first. But we're A-okay here because they're already in order. Let's do one more example. Multiplying binomials together. We have 3x minus 4 times 2x minus 5. At this point, if you have not tried an example on your own before checking your work with mine, you need to definitely do that. We've gone through a couple of examples. It's time for you to take a shot, if for nothing else, to see how well you're getting it. If you get it completely wrong on your own, that's a good sign. You should pause the video and shoot me an email. Say, hey, I'm really struggling with multiplying binomials. Okay, again, the key to this whole deal, binomial times binomial, and really anytime we have multiple terms being multiplied by a different polynomial that has multiple terms, you got to make sure you distribute everything. 3x times 2x and 3x times minus 5. I'm going to get 6x squared minus 15x. Now I got to distribute that minus 4 times 2x and minus 4 times minus 5. And I get minus, write it in the same color, minus 8x plus 20. Identify the like terms. up with 6x squared minus 15 and minus 8x is going to be minus 23x and plus 20. Folks, a lot of you are struggling with subtracting negatives and getting positive 20 here, multiplying two negatives. Negative 4 times negative 5 gives me positive 20. If you struggle with that, I encourage you to do these in your head, these little multiplications, subtractions, and additions, but please double check them with a calculator. And if you find yourself consistently getting them wrong, talk to me so I can help you out. Negative 15 minus 8 gives me negative 23. And negative 4 times negative 5 will give me positive 20. Again, this is a great point to pause the video. If you're struggling still with multiplying binomials, make a star in your notes. Shoot me what questions you have. All right, let's keep on going. Now that we know how to multiply binomials, or at least we've been introduced to it, let's try a more practical problem with it. Let's say that my outer rectangle has a length of 2x plus 5 and a width of 3x plus 1. My inner rectangle has a length of x and a width of x plus 2. Don't need those parentheses, but they're not going to hurt us. What I want you to do is the following. I want you to try and find the area of the small rectangle. I want you to try and find the area of the big rectangle. And then I want you to find the area of the shaded cyan region. Not only do you need to multiply binomials, but let's apply this. Let's get our brains thinking, okay? I want you to be able to think through problems. So go ahead and give this a shot. Well, hopefully you have given this a chance. You've tried it. And if you found yourself stuck, you're like, man, I really don't know what to do. Let me show you how to find the area of the big rectangle, and maybe that'll open your eyes to how we find the area of the small rectangle. So finding the area of the big rectangle. Well, first of all, how do I find the area of a rectangle? We think back to our middle school days, and we know that the area of a rectangle is length times the width. Length times the width. So to find the area of the big rectangle, I need to do my length times my width. And when I multiply these together, I'm going to end up multiplying two binomials. So let's go ahead and do it. 3x times 2x gives me 6x squared. 3x times 5 gives me, let's use a little bit, gives me 15x. 1 times 2x gives me 2x. And 1 times 5 gives me 5. Again, combine my like terms. And I get 17x, 6x squared plus 17x plus 5 as the area of my big rectangle. Again, at this point, go ahead and solve your, see if you can solve number 1 and number 3 now. There's the answer for number 2, 6x squared plus 17x plus 5. And see if you can find the area of the small rectangle and then the area of the shaded region. Well, hopefully at this point you've now attempted to find the area of the small rectangle. Again, apply your same logic, length times width. And with these, because of the commutative property, the fact that I can reorder my multiplication, it really doesn't matter the order I set this up in, whether I do length times width or width times length, you still get the same. When I do this, I get x times x is x squared, and 2 times x is 2x, And so that would be the area of my small rectangle. And applying the idea that area equals length times width. So the question becomes, how do I find the area of the shaded cyan region? Well, again, let's take some time and just think about it, and then we'll solve it. The big rectangle here, we already found the area for that. We found the area for the small rectangle. Well, what is the shaded cyan region? Well, if we think about it, it's all the area in the big rectangle. We'll call that BR, all the area in the big rectangle. The cyan region's all the area in the big rectangle minus the white chunk, which is the area of the small rectangle. And that's the cyan region. So if I take away the small area of the small rectangle from the area of the big rectangle, that will give me the cyan region. It's going to cut that chunk out. So I need to do the area of the big rectangle minus the area of the small rectangle. Well, how would we set this up? Well, the area of my big rectangle, we said, is the outer length times the outer width minus, we got to do this area of the small rectangle, which we said was the inner length times the inner width. And now, if we solve this, we will find the area of the cyan region. Now, you might look at this and go, man, that's really complicated. Folks, it's really not. Handle your parentheses first, as order of operations would say, then handle the subtraction. I've got two specifically. If I'm looking at my parentheses, I can't simplify in the middle. So if you would move down your chart of order of operations, you have these two things multiplied together, and then you have a subtraction in the middle. According to order of operations, handle your multiplication before your subtraction. What does that mean? That means handle multiplying these out, then worry about subtracting. Well, if I do multiply out my first binomial, I'm going to get 6x squared plus 2x plus 15x plus 5 minus x squared plus 2x. Area of the big rectangle minus area of the small rectangle. Now, why did I throw those in parentheses? Because we want to keep included the whole area. Specifically, the reason I'm doing that is because of this minus sign. That minus is going to apply to the whole area. If I don't put the parentheses there, the minus would only be applying to the x squared, which isn't true. The minus applies to x squared plus 2x because that's the area of our small rectangle. So we make sure we throw the parentheses in appropriately. Okay, that way the minus applies to the whole small area, x squared plus 2x. And now this actually looks like a problem from 9.1. I'm going to distribute my negative through. And maybe you already did that in the step above, which is fine. I can just drop the parentheses on my first polynomial because there's nothing out front of it. Although I'm actually going to rewrite this first polynomial because I noticed just now there are like terms I can combine. I distribute my negative, making sure I distribute it to both terms. And now again, I'm going to look to combine like terms. And I end up with 5x squared plus 15x plus 5 as the area of my shaded cyan region. So we're now applying where we used to use just basic numbers. We are now applying our knowledge of binomials to find the area of different rectangles. And I hope you see that above. Applying some critical thinking with our knowledge of multiplying binomials and combining like terms. Again, what I hope you see in the work there is the order that I work through stuff. A lot of it goes back to order of operations. If you get in trouble, you're going to get in trouble if you work on your subtraction before you multiply out your binomials, or in this case, here on the right, the monomial times the binomial. So make sure you remember your order of operations and handle your multiplication first. Make sure we have parentheses around the x squared plus 2x, because that's the whole area of the small rectangle. So the minus needs to apply to that whole thing. Distribute your minus and then combine our like terms. Again, if you struggle with that, let me know and I'll be happy to help you. All right. To conclude the lesson, let's do 2 final examples. Okay, if you can get these, you're in really, really good shape. Let's do 4x squared plus x minus 6 times 2x minus 3. And we'll do 6n minus 8 times 2n squared plus n plus 7. Now you look at these and they probably look pretty similar, but now we aren't multiplying together 2 binomials. We're actually multiplying together a trinomial and a binomial. Okay, in each case. The second one's a binomial and a trinomial. Again, nothing changes. Same logic. Everything in the first polynomial needs to be multiplied by everything in the binomial. So how am I going to solve this? I'm going to distribute everything, or that's backwards. I'm going to distribute the 4x squared to everything in the second binomial. And I'm going to get 8x squared minus, or 8x cubed, 8x cubed, because I like bases multiplied together, add the exponents, 2 plus 1 is 3, minus 12x squared. And you can see I'm going to be really methodical about this. That way I don't miss anything. I almost exclusively work left to right here. Now I'm going to multiply the x by the 2x and the minus 3. And I get plus 2x squared minus 3x. Then I'm going to do 6 times 2x, or negative 6 times 2x, and negative 6 times negative 3. And I get negative 12x plus 18. Few more numbers and a few more sets of like terms, but again, the process didn't change. 8x cubed does not have any like terms up here, so it just comes down. We can combine the negative 12x squared and the 2x squared to get negative 10x squared. Negative 3x and negative 12x can be combined to become negative 15x, and then the plus 18 just carries on down. So we get 8x cubed minus 10x squared minus 15x plus 18. At this point, I would encourage you, well, I got to finish writing down the problem, to try this last one on your own. Make it a marker for yourself. How good am I at distributing binomials? Okay, give this one a shot. Okay, hopefully you've tried it. Check your work with mine. Again, I'm very methodical about this. I'm taking my first term in my first set of parentheses and distributing it to everything in the second set of parentheses. When I do that, I get 12n squared plus 6n squared plus 42n. Distribute my negative 8 as my second term to everything in the second set of parentheses, and I get negative 16x or n squared minus 8n minus 56. Combine my like terms. I have, oh, I made a mistake. This should be 12n cubed, because the 6n times the 2n squared makes 12n cubed, which I don't believe has any other like terms. We then have a 6n squared and a negative 16n squared, like bases, like exponents. Those will combine to be negative 10 n squared. We have a 42n and a minus 8n, which will combine to be plus 34n. And our minus 56 will travel down with us. Guys, this will conclude the end of the 9.3 video. Thanks for watching. And the big thing to walk away with, when you're multiplying binomials, polynomials, trinomials, monomials, make sure you distribute everything to every part of each binomial. Okay, thanks for watching. Good luck.